There is a revolution going on in the automobile industry, with electric vehicles taking over the whole transportation sector. However, the whole world is yet to know about a shocking new invention that will turn the whole electric vehicle upside down by a group of German engineers. What have these researchers invented, and how will it change the EV industry forever? Stay tuned as we bring you how German engineers present a world record engine that changes everything. Electric vehicles have grown in popularity in recent years as a result of their environmental benefits, lower operating costs, and technological advancements. EVs are divided into two types: battery electric vehicles, or BEVs, which only utilize batteries to store power, and plug-in hybrid electric vehicles, PHEVs, which combine batteries with an internal combustion engine that can be recharged from an external source. The global EV industry has grown at an exponential rate over the last decade, with sales exceeding 10 million in 2022, up 55% from 2021. In 2022, EVs will account for 14% of total car sales, more than 10 times their share in 2017. The forecast for EVs is promising, with sales predicted to remain robust through 2023 and beyond. According to the International Energy Agency, IEA, EV sales might reach 14 million by the end of 2023, a 35% rise year-on-year and an 18% market share. And one of the most important parts of an electric vehicle is the electric motor. An electric motor transforms the electrical energy into mechanical energy, which subsequently powers the wheels. Electric motors provide numerous advantages over internal combustion engines, including higher efficiency, reduced pollutants, less noise, and less maintenance. Electric motors of several types can be used in electric vehicles, including brushed DC motors, brushless DC motors, and induction motors. Each variety has its own set of qualities, advantages, and downsides. Brushed direct current, or DC motors, are the most basic and extensively used form of electric motor. They're made up of a permanent magnet, stator, and a wire coil rotor, which spins when a direct current is provided. A commutator, which swaps the contacts of the brushes that connect the coil to the power source, reverse the current direction. Brushed DC motors are simple to use and may generate great torque at low speeds. Now, brushless DC motors are comparable to brushed DC motors, except that they lack brushes and commutators. Instead, they employ an electronic controller to switch the current in the coils based on the rotor's location. Brushless DC motors can run faster and make less noise than brushed DC motors. They are, however, more complex and expensive than brushed DC motors, and their operation necessitates the use of a sophisticated controller. Another form of electric motor that does not use permanent magnets or brushes is an induction motor. They employ alternating current, or AC, to create a magnetic field in a wire coil rotor surrounded by another wire coil stator. The magnetic field causes the rotor to spin in time with the frequency of the alternating current. Induction motors are simple and durable, withstanding high temperatures and voltages. They are also less expensive and less heavy than permanent magnet motors. Now, the ideal type of electric motor for an electric car is determined by several criteria, including the car's performance, cost, weight, and size. Various electric car manufacturers employ various types of electric motors in their models. Tesla, for example, employs induction motors in the Model S and Model X, and has transitioned to permanent magnet motors in the Model 3 and Model Y. And permanent magnet motors are used in the models of other electric car manufacturers like Nissan, Hyundai, and Volkswagen. And Toyota and Honda, for example, utilize hybrid systems that mix electric motors with internal combustion engines. Efficiency, defined as the ratio of output power to input power, is one of the most important aspects considered by EV designers. Higher efficiency translates to less energy loss and more range for the EV. Permanent magnet synchronous motors, PMSMs, have the best efficiency among electric motors, ranging from 92 to 97%. Another key aspect is power, which is the rate at which work is done or torque is produced. Higher power means the EV will accelerate faster and reach a higher top speed. The power of a motor is determined by its voltage and current, as well as its torque and speed. Torque is the force that causes the wheels to rotate or move. Higher torque equals more pulling force and a stronger capacity to climb hills for the EV. Torque is affected by the motor's current and magnetic field as well as its speed and load. Then there is speed, which is the rate of rotation or movement of the wheels. For the EV, faster indicates more travel distance per unit time. The speed of a motor is determined by its voltage and frequency as well as its torque and load. You also have to consider the cost of the motor or the amount of money necessary to purchase and to operate it. Lower costs imply that the EV will be more affordable and profitable. And size matters too. A smaller size implies the EV takes up less room and weighs less. The size of the motor is determined by its power, torque, speed, efficiency, and cooling requirements. Now, engineers are always working to improve the electric motor, and they even compete among themselves, which is a gain for the consumer at the end of the day. One such company is the German company Mahler, which develops and manufactures electric motors for EVs. A team of experts with a vast experience in the automotive and aerospace industries launched the company in 2017. Mahler's vision is to provide innovative and sustainable mobility solutions for the future. And one of Mahler's main products is a revolutionary electric motor with an efficiency of 95 to 96%, which is comparable to that of Formula E racing cars. This motor is a current-excited synchronous machine, which means that its magnetic field is controlled by electromagnets rather than permanent magnets. This results in improved controllability and flexibility, as well as less reliance on costly and precious rare earth elements. Mahler's motor also has wireless power transmission to the rotor, which eliminates the need for brushes, slip rings, or mechanical contacts. This decreases the material wear and friction losses found in other electric motors. Power is transmitted by induction, similar to how your cell phones are charged wirelessly. The power density of Mahler's motor is 6 kilowatts per kilogram, and the torque density is 10 newton meters per kilogram, both of which are among the greatest in the industry. The motor can be built for any performance class, from small city cars to heavy-duty trucks. The modular design of the motor enables simple integration and customization. Mahler's motor has piqued the interest of automakers and suppliers worldwide, who regard it as a game-changer for the EV business. Several contracts and relationships with renowned companies in Europe and Asia have already been secured by the company. Mahler aims to begin mass production of its motor in 1 to 2 years, depending on customer demand and interest. Mahler's electric motor operates on the basis of a current-excited synchronous machine, which is a variable magnetic field alternating current AC motor. Electromagnets attached to the stator, the motor's stationary component, generate the magnetic field. The electromagnets are linked to a power supply and a controller that controls the current and frequency of the alternating current. The rotor or rotating portion of the motor is made of laminated iron and includes conductor holes. Both ends of the wires are short-circuited, making a closed loop. When the rotor spins, the conductors cut through the stator's magnetic field, causing an electric current to flow across them. This current generates a magnetic field in the rotor that opposes the magnetic field in the stator, resulting in torque that causes the rotor to spin faster. Mahler's electric motor has various technical features that distinguish it from other electric motors. The motor's efficiency is 95 to 96%, which means it transforms the majority of the electrical energy into mechanical energy with little losses. This is higher than the typical efficiency of electric motors, which is 80 to 90%. The motor's high efficiency minimizes the EV's energy consumption and emissions, as well as the heat generation and cooling requirements of the motor. The motor has a power density of 6 kilowatts per kilogram, which means it can produce 6 kilowatts per kilogram of mass. This is greater than the usual power density of electric motors, which is 2 to 4 kilowatts per kilogram. The motor's high power density allows it to provide more power with less weight and volume, making it ideal for tiny and lightweight EVs. And with a torque density of 10 newton meters per kilogram, the motor can produce 10 newton meters of torque per kilogram of mass. This is greater than the normal torque density of 4 to 8 newton meters per kilogram for electric motors. Because of the motor's high torque density, it can provide more torque with less weight and volume, making it ideal for heavy-duty and high-performance EVs. and the motor has a speed range of 0 to 20,000 RPM, which means it can run efficiently at both low and high speeds. And this is higher than the average speed range of electric motors, which is usually 0 to 10,000 RPM. The motor's vast speed range helps it to adapt to a variety of driving circumstances and scenarios, including city traffic, highway cruising, and off-road driving. And what's more, the motor has a wireless power transmission technology that transfers power from the stator to the rotor via induction. Brushes, slide rings, and mechanical contacts are no longer required, which are prone to wear and tear, friction losses, sparking, and noise. The wireless power transmission method increases the motor's reliability and durability, as well as the EV's safety and comfort. As a result of all of this, Mahler's motor fits into many applications like tiny urban vehicles. The motor can be utilized in tiny urban vehicles that demand high efficiency, low noise, and low emissions, such as 3- and 4-wheeled EVs. The motor has enough power and torque for city driving, as well as a small and lightweight design that matches the vehicle's limited space and weight. Heavy-duty trucks. The engine can be utilized in heavy-duty trucks, including delivery trucks, garbage trucks, and construction trucks that require a lot of torque, performance, and dependability. The engine has considerable torque and power to handle big loads, steep hills, and rugged terrains, and it has a sturdy and durable design that can resist severe conditions and long distances. And a final application it's highly suited for is high-performance cars. The motor can be used in high-performance vehicles such as sports cars, supercars, and hypercars that require a lot of power, speed, and control. The motor has excellent acceleration and peak speed power, as well as flexible and accurate control for handling and braking.